organism adapts to stress. And when we think of an athlete and physical training, really we're just looking for that athlete to physically adapt to the stress that we're imposing on their body. So initially, an athlete comes in for a session and they have a baseline of fitness, and then as they get fatigue sets in, their fitness level falls. Basically, if you follow this line here, it falls. As they recover, all right, that line starts to trend upwards past that baseline of fitness to what we call supercompensation at that apex point. All right, so basically, as a sports performance coach, we try to stack those supercompensations together over time to maximize fitness. All right, if we are to go beyond that supercompensation apex, we actually get into detraining. We don't want to get there. All right. So when we look historically, the three periodization models that have been used the most frequently by researchers and performance coaches is linear periodization, which is a physical training which involves a gradual, progressive mesocycle increase in intensity over time. Typically what happens if we take, for instance, a back squat, typically what happens is day one, an athlete would come in, they may do, let's say, 5 sets of 10 on a back squat. That's going to be 50 reps. It's going to be a lot of volume, but they might do it at a lower intensity, maybe like 50 to 60% of their 1 rep maximum. All right, and by session 10, we might be doing 10 sets of 1, which is only going to be 10 reps at 90% of that 1 rep max of their back squat. All right, undulating periodization, also known as nonlinear periodization, is physical training which involves large daily fluctuation in load and volume assignments. So if we take a similar example to the one I just have, on a Monday we might do 5 sets of 10 of back squat at 50%, but on Wednesday we might back squat again and do 10 sets of 1 at 90% of 1 rep maximum. So there's big fluctuations throughout the week. All right. The last one is block periodization or concurrent periodization, and really with that we're looking at different biomotor abilities. So let's say we're training strength. All right, we're going to emphasize strength in block 1, and we might de-emphasize power and speed. In block 2, we may emphasize speed and de-emphasize strength and power, and then so on. And we just kind of sequence that up based off of where we are in the training. This is kind of more of a visual aid for you guys on those 3 models. Linear periodization, as you see, we start with high volume, and as the volume decreases, the intensity increases. Undulation, like I said, big shifts in volume throughout the week, all right, or a microcycle. And then I have an example of block periodization when it comes to bodybuilding, but like I said, if we were to look at it as sports performance, that green on that first block may be speed, and blue may be power, yellow may be strength, and then we start to emphasize different biomotor abilities over the course of time, all right. Traditionally, this is what an annual plan is going to look like. This is actually an annual plan preparing a sprinter for the 2004 Olympics. As you can see, it goes into a lot of detail, what volume intensity we're at, as well as different biomotor abilities that we're kind of emphasizing over the course of a mesocycle or macrocycle. So, all this talk about all that stuff, but what is fluid periodization? So, with the advent of a lot of devices, we were able to take some more objective measures when it comes to our athletes. So a lot of you probably have an Apple Watch, a Whoop band. That's some of the daily devices that a lot of people use. But we also, in sports performance, we have, for me especially, I'm blessed to be able to use a lot of these tools. We have tools like force plates, omega wave technology, GPS units that we can track volume with. So basically, with that being said, fluid periodization is physical training which adjusts volume and intensity based upon the physiological assessment of individuals with objective measures. Kind of like I just mentioned, a lot of these devices up here are some of those devices that I was talking about. Really, historically speaking, we have a long-term approach to sports performance where we do that reverse engineering years in advance of where we want to be. But really, especially when you work with team sports, we have to realize that given individual variances between athletes, all loads acting on an athlete must really be assessed properly to monitor the body's ability to adapt to functional stress. Every athlete is different, Every athlete is a different anomaly. They're going to respond to stress differently. So why wouldn't we take objective measures to be able to adjust that volume and intensity based off of where an athlete is day to day? All right. A lot of those devices are athlete monitoring systems. In order to properly guide the training process, coaches must be able to identify an athlete's readiness to train. And readiness is really being the current functional state of an individual that determines their ability to achieve their performance potential. The use of athlete monitoring systems allows for optimal application of training volumes and intensities, kind of like I mentioned before. Now, what are some of those metrics that we look at, some of those objective metrics that we look at to change that volume and intensity on a day-to-day basis? First one's going to be heart rate variability, which is really something that a lot of us can do by ourselves. If you have an Apple Watch, you can actually track it. A Whoop, you can definitely track it. It kind of gives you your strain score day to day. But basically, it's a measure of the amount of time between your heartbeats. I know a lot of us probably think that our heartbeats pretty much maintain the same amount of time between each heartbeat all the time, but there's actually minimal difference between the time between each heartbeat. HRV is linked to the automatic nervous system, and the use of HRV as a measure for recovery has been shown to be beneficial in guiding the training process. The other one's a little bit more complicated. It's direct current potential of the brain. Basically, DC potentials denote sustained shifts in slow deflections of cerebral potential superimposed with conventional EEG waves and reflect alterations in the excitation level of the cerebral cortex and subcritical structures. That's a lot, but basically it's the way that different portions of the brain communicate with other portions of the brain and the body. All right. So one of the studies that I'm briefly going to discuss, it's really actually the only study on fluid periodization that's been published thus far. It is the effect of fluid periodization on athletic performance outcomes in American football players. It was done by a gentleman named Christopher Morris at the University of Kentucky with the football players there. And the purpose of the research was to examine the effects of fluid periodization on performance outcomes in American football players. As far as methodology, these are it's a convenient sample of 59 Division I American football players, like I said, all at the University of Kentucky. This is kind of a breakdown of the control group and the experimental group by class or year, whether they were a freshman, sophomore, junior, or senior. As far as experimental design goes, the study utilized a longitudinal comparison between two non-randomized groups. The treatment group used fluid periodization as their independent variable. The control group used block periodization as designed by the strength and conditioning staff at the University of Kentucky. The dependent variables were anthropometric measures and performance outcomes tests that we'll kind of get into in a couple of slides. All right, so the device that they actually use to measure both DC current potential and HRV is actually called an omega wave. And the testing protocol for their omega wave, basically the athletes self-administered the test within 30 minutes of waking up. They had to do it in a calm and quiet environment. The intake of food or caffeine was not allowed prior to testing, as it would discourage. It might prevent any disruption. It might prevent a disruption in automatic tone. As far as resistance training protocol, these are the exercise. This is the exercise selection that they use over a course of an 8-week training block. They actually broke it into two blocks, 3 hard weeks followed by a deload week. There's no sets and reps on here because the experimental group actually changed intensities and volumes based upon the readings that they got from that omega wave. To get into the results briefly, this is a table of all the things that they measured over the course of time. As you can see, there's significant increase in the experimental group and the control group in vertical power, broad jump, and aerobic efficiency. And this is, practically speaking for me, this is one of the biggest findings that I found. It's really, as a coach, we write things down on paper, but they might not make sense when it comes to how an athlete is actually feeling for the day. As you can see, as far as volume for the different exercises, core volume, there's a 10% difference between the experimental group in the control group as far as volume goes. So that, I mean, that's huge. They did almost 2,000 less reps than the control group. And as far as accessory volume, there's almost a 13, a little bit over a 13% difference from the experimental group to the control group. This is kind of showing what I've already said. This is probably one of the biggest, most significant differences in the study. The experimental group's aerobic efficiency well surpassed that of the control group, and this kind of shows a little bit more as far as efficiency scores for all of the metrics that I just mentioned. In conclusion, while training volume and intensity should be assigned to a group of athletes, we must realize that each individual is their own genetic anomaly, which responds and adapts to stress in a unique and unpredictable manner. And is there any questions? I know that was a lot.
Yeah, sorry. If there's any questions now, sorry.
Do you actually use EEG?
So no, I don't. That was a study done. So I don't have Omega Wave technology available to me right now. But you can also, there's other objective measurements that you can use. So like at Sanford, we have force plates. Basically, it's a plate you stand on, you jump. It can read something called MRSI, which is reactive strength index. So what we'll do is we'll have the athletes jump every day. And if their RSI may be trending down, we know, okay, this athlete is fatigued. We need to maybe drop their volume or intensity. But there's a ton of technology out there you can use nowadays. Some teams have Whoop. They'll have everybody on Whoop devices, and they'll be able to read their HRVs from day to day. If they come in with a super high HRV, then they know, okay, we need to maybe decrease a little bit what this person's doing. Other than that, I don't know if that answers your question. I don't have EEG available to me. Unfortunately, maybe one day, but not yet.
Yeah. Well, maybe it's a silly question because it's about the other study, but did it mention if maybe anybody broke protocol? Because I know you said it's strictly in the morning and no caffeine.
one of the problems with that research is it is self-administered by the athletes, and sometimes athletes are not that reliable. So there was an 87%. There was an 87% like follow rate. Like there was 87% of the people did it on a day-to-day basis.
That's still pretty good.
It's pretty good for football players.
Well, it's good for anybody, really. But yeah, sure. Okay, well, I don't want to hog you. Any other questions? Well, if not, let's thank the speaker again.
Thank you.